Okay, so as you walked in, you should have noticed the board said, come in quietly, get your interactive notebooks, your EMs, they're in the middle of your desk, and get your glossary of scientific terms and something to write with. I'll give you about 20 seconds.
You don't have to do that.
Does everybody have it? Alright, so today we're going to be talking about what is essential for birds to survive. So talk amongst yourselves, and then I'll ask you. I'll give you about 20 seconds to come up with something. So the question is, what do birds need to survive?
Food. What else?
Food, okay.
This is in our notebook.
What else we got?
Air.
Air.
Feathers.
Air.
She means oxygen.
Alright. Oxygen.
Water. Feathers.
Water. Feathers. What else? Anything else?
A place to
A-
stay away from
Nest.
What do we call that? though?
Nest.
A nest?
Habitat.
A habitat or a shelter, right?
shelter.
Shelter.
Breeding or mating.
What?
Mating.
Mating?
Yes.
Well, they don't need a mate to live.
Okay. If they don't mate, then you're not gonna live no more.
Okay. Alright, so today we're going to focus on their food supply. So in your journal, go ahead and open up to your next availables page.
Oh, journal.
I need you to write your essential question. It is, how does adaptation enable birds to survive in their environment?
Write the question down.
How does adaptation enable birds to survive in their environment? So this is what we're going to be answering. How does adaptation, who can tell me what adaptation is? Yes, Victoria.
It's how when like Darwin or whatever, when the beaks form so that they can eat certain things.
So that they can eat certain things, yes. Is there anything else that you know can adapt?
Like when an animal adapts to the environment.
Okay, give me an example of that.
Example. I will let the phone friend.
Huh?
He has the phone in front of him.
Oh. Yes, you can ask your neighbor instead of saying I don't know. How do we ask our neighbor though? No, you say their name.
Veronica, can I tag you in?
No, you may not. Yeah.
Okay, so we don't know, but we know it happened, right?
Yeah.
Okay, so,
Ooh.
yes.
I know.
Yes.
The dodo birds, they used to fly, but then there wasn't that many predators around, so and most of the food was on the ground, so they stopped flying, and they didn't need to fly no more, so they did everything on the ground, and there was no predators. But then when it was introduced, they all died out.
So
Because
that's-
they couldn't fly out anymore.
That's an example of not adapting, because now
Oh
they're
yeah, because they didn't make it better.
Okay,
Yeah.
alright, so I need you to write this. What do you think would happen if the food supply of birds decreased? So write the question and go ahead and answer it. Once you're done, raise your hand and I'll check it. There is no wrong answers, but you need to write something. So what would happen if the food supply of birds decreased? Write it down, Hyman. I can see it's real good, it's got you.
No. I got the answer to the first question.
Oh, well, we moved on. Write it down and we'll come back to it.
Alright, let's start this.
battle of the fittest.
Oh, I like that. All
Hunger
right.
Games.
And then they come extinct because they're just killing each other.
Nice. Good job.
Take you.
Are you set? I like that. Nobody said anything about going somewhere else. Alright. And with Donna.
Death.
Okay. Nice. You used what we just talked about. You made that connection. Victoria, can you read yours out loud?
The birds would adapt to the new environment they would eat what was available.
Okay, so hypothesis. It can't be wrong. So now we're gonna watch a video. After the video, we're gonna compare what you thought would happen to what the video says would happen. You can take notes because they're gonna help you answer questions later on.
Our planet has millions of species. Over 300,000 beetles alone. 17,000 butterflies. Thousands of mammals, fish, and birds, all astonishingly different. How did so many species come to be? To seek insights into that question, researchers are focusing on places where species recently arose, such as the remote Galapagos Islands.
Scientists are making observations and conducting experiments that would have surprised Charles Darwin. And they're discovering new insights into what the great naturalist called the mystery of mysteries. How new species form.
The Galapagos Islands are one of the most spectacular landscapes in the world, home to a variety of species that live nowhere else. Biologists Peter and Rosemary Grant have been seeking answers to how species arise by focusing on one of the smaller islands, called Daphne Major.
When we started out, we had no plan for the long term. In fact, we thought it was just going to be just a few years, maybe 2 years.
2 years have turned into a 40-year odyssey. The Grants have returned every summer since 1973. Here, they've made some of the most remarkable observations in the history of field research as they studied the famed Galapagos finches. The finches were first brought to scientists' attention by Charles Darwin when his voyage around South America brought him to this cluster of islands, 600 miles from mainland Ecuador. These volcanic islands are geologically young. They began rising from the ocean floor less than 5 million years ago. At first devoid of life, they now support a modest number of species. Among them, 13 species of finches, found in various combinations on the different islands. The birds live in diverse habitats.
The islands are very different from each other. They differ in size, they differ in topography, and in height.
Larger trees grow at higher elevations, while low islands have mostly cactus, grasses, and shrubs. In these diverse habitats, the finches have evolved many ways to survive.
So, Rosemary, what's the important difference between these birds?
This little warbler finch with its very fine needle-like beak is perfect for picking off insects. This one is the woodpecker finch with a rather more robust beak. It concentrates on beetle larvae and termite larvae. Then we have the cactus finch with a much longer, sharp, pointed beak which probes into cactus glass. And then these three species are the large, medium, and small ground finches. So, Sean, the basic idea is the beaks are tools, and you need the right tool for the right job.
The finches look so different that Darwin first mistook them for entirely unrelated kinds of birds. How did the Galapagos end up with so many species of finches?
In terms of the actual history of the finches of the Galapagos, there were many different possibilities. Different kinds of finches could have all come from the mainland separately, or the finches could have all evolved out there on the islands. And what do we know about that?
Well, now we know from DNA evidence that all of the finches are more related to each other than any one is to a species on the mainland. And that tells us only one species arrived on the archipelago and diversified into the 13 species that we see nowadays in the Galapagos. So they've all come from a single common ancestor.
The question then becomes, how did one ancestral population give rise to many different species, each adapted to a different lifestyle? A crucial insight into how adaptation occurs came when the grants focused on one species on the island of Daphne Major.
There's our vocabulary word, adaptation.
A factor of great convenience for us was the small size of the island. That meant that we could walk all over the place.
Oh, there's a bird.
I'll leave that one to you.
The idea was that if we worked really hard, we could follow every individual or almost every individual.
They rose at 5:30 each morning to net the island's medium ground finches. They measured the size and shape of each bird's beak, the bird's weight, and they tagged them for identification.
The male is 17.8.
Year after year they returned, at times tracking over 1,000 finches.
So here's an example of a bird we know intimately over the whole of its lifespan. The number is 5960. We know how many times it bred, which years it bred in, how many mates it had, how many offspring it produced, and then how many of those offspring themselves survived long enough to breed.
Over the first 4 years, little seemed to change. Then in 1977, a terrible drought began.
Virtually no rain fell for the next 18 months.
The vegetation practically disappeared, apart from a few trees without any leaves, and of course the cactus bushes were still there.
Now the medium ground finches had to compete for scarce food.
They started off with a big food supply of small seeds, medium seeds, large seeds. As these small seeds became very scarce, they had to turn increasingly to the large and hard seeds. But only birds with large beaks can crack open these woody, spiny fruits.
The birds with the smallest beaks had the most trouble.
They were scraping about amongst the rocks, and their plumage got so worn that they could barely die.
That year, over 80% of the medium ground finches died.
We would go around looking for birds that had died, and it's very sad to pick up a bird and say 3972. Oh no, not that bird. Oh.
When they inventoried the surviving medium ground finches, they discovered that one trait had made the greatest difference between life and death.
Well, I'm showing here a distribution of beak depths of the population in 1976. The survivors of this group are shown in black.
Oh. So the larger the beak, the better your chances.
The larger the beak, the higher the likelihood of surviving through the drought of 1977.
18.6 grams. When they looked at the offspring, they found an even greater surprise. The average beak depth was more than 4% larger than the previous generation.
So what happened?
Natural selection had changed the average beak size. Could you have ever imagined measuring and observing something like this on such a short time scale until you actually did it?
When we started, the answer is no. We could not imagine we would be able to do it.
But was this a fluke? Or are changes like this happening all the time? 5 years later, in 1983, an unusually strong El Nino brought 10 times more rain than normal. And the island was overrun by vines that covered even the cactus. The rains changed the vegetation on the island, such that 2 years later, when drought struck, larger seeds became scarce. The birds with larger beaks now had difficulty picking up the more abundant food, the small seeds produced by the vines. That year, many more finches with small beaks survived, and their offspring inherited smaller beaks.
So the selection had swung in the opposite direction and evolution had occurred as a result.
In an amazingly short period of time, the Grants had measured evolution of beak size not once, but twice, demonstrating that when birds encounter different environments, they will change over a very short amount of time.
Okay. So now I want you to compare what the video said to what you said. What was different? What was the same? Loretta, what did you?
For my two answers, I put they would go extinct, and they would start killing their own. But in parentheses, I put survival of the fittest. So I think that's the only thing that correlated with the video was that the ones that were fit for that environment are the ones that survived. But some of them did die though, but they didn't go extinct.
There you go. So yes. So Jaime,
Yes.
compared to what you wrote down originally, your hypothesis.
Well, I wrote that the birds would die.
Okay. So did the movie support your
Yeah, for the birds died.
bird's eye? Okay.
I'm right.
It's the same, but like Loretta said, whoever was known for that, when there was no water and you were bigger birds are the ones that survived. I see where I wrote that.
So you were half right. You just needed to know that. Yeah.
Well, I said that there were the birds would die, which is what happened, and I also said that the birds would migrate to other places, which is not true because they adapted.
They adapted, right? All right.
So how was right?
All right. So what is adaptation?
It's an alteration in the organism, behavior, or body.
Change to survive. I like those. Let's combine those. And adaptation is a special skill which helps an animal to survive and do everything it needs to do. Adaptation could be a physical change, like we saw the beaks on the animal's body, or a behavioral change in how an individual or animal or society do their things in daily lives. All right, so write that down. again. When you're done writing it down, go ahead and take out your glossary. We're going to add the word adaptation. So, you have our glossary of scientific terms. Turn to your page A. We did Adam before. Now we're going to add adaptation. So adaptation will be our term. We're going to fill in our definition. You can shorten it because I like your answers. You had great answers. And then I want you to show me an example. You can either write one or draw an example of what you think adaptation looks like. So you can go ahead and color it. That way it'll help you remember. So what does adaptation mean to you? All right, Loretta, did you finish your glossary?
I just drew a picture of the beak, how the beak was 30 years ago and how it was 20 years ago.
Okay. All right, so since Loretta's done, let's go ahead. Our exit ticket, when you're done, just come get an index card. Your exit ticket is, if you could adapt in any way, what would it be? Well, and why? Why would you adapt that way?
Maybe anything?
Any adaptation that you feel. As you're filling that in. So what adaptation enabled the birds to survive?
The change in their beak.
The change in their beak, yes.